Welcome back. This is Prof G, and this is the solution for question number 9 in the 9-question, 2.5-hour midterm exam for my physical computing course. This is the sentiment meter. It's meant to mimic the knobs that pollsters sometimes use to have people watching candidates rotate to indicate whether they are positively or negatively inclined toward a statement. Let's take a look. So again, this is supposed to be used to assess a person's sentiment when listening to a political candidate or watching a movie. The more red lights, the greater the negative impression. The more green lights, the greater the positive impression. A neutral impression should indicate no lights. So dialing the potentiometer should return 11 evenly spaced values. If the potentiometer is dialed in the middle, that would be value 5 on a 0 to 10 scale, then all lights are off. Turning to the right or clockwise, and red lights should show increasingly in the lights 4 through 0, indicating a negative opinion. Scaled potentiometer values will move from 6 through 10. And then if you turn left, the green light should show from 5 through 9, indicating a positive opinion. Scale potentiometer value should move from 4 through 0. This is an example of how things should look when they're working. We're even now. Let's see what happens if we dial to the left. So we're indicating we have a negative opinion. If we start to dial toward the right, we're at neutral, right in the middle, but keep going to the right, and we indicate we have a positive opinion. So notice how the lights move around from left to right. You can see them going in a circular pattern. Let's see how to build this. So when we set up this question, we want board neopixel time digital I/O, and because we're using our potentiometer, we want to make sure that we import analog in from analog I/O. We've set up our pixels the same way before in our various questions. We're going to need the colors black for turning off all the lights and red and green, and we set up our potentiometer. We're going to call a potentiometer with an analog in board.A3. Always remember when working with a potentiometer that you want to make sure that power goes into the 3.3 volt pad, not in V out. If you put it into V out, you're going to get the wrong readings from your potentiometer. Now, inside of our while loop, this is where the bulk of the calculation happens. Now, first we want to get the dial value. So we want to find out which value we have in that 0 through 10 value, the 11 different choices that we have on the dial. So the way that we can calculate this is with a fairly familiar calculation. What we're trying to do is scale a reading from 0 to 65,520 to a reading from 0 to 10. We could use int, but as you've learned in your videos, round is much better. And we're going to take the potentiometer value, which is a value between 0 and 65,520, and we're going to divide that by the value of 65,520 divided by pixels num of lights plus 1. So pixels num of lights, remember, is 10, but we want to add one more so that we're going to be able to have a place for the neutral value in between the two sides as well. So this is going to give us our number from 0 to 10, or one of 11 values. Now, I always recommend that you use print statements so that you can get a sense of what your code is doing at different points in time. So I put a print statement in here. You didn't have to do that as part of the tests, but I recommend it. You want to go through all 11 possible dial values. 10 through 6 are the left or red side. 4 through 0 are the right or green side. And 5 is right in the middle. That means no lights. Now again, this diagram here that was on the question itself is meant to show you what you're going to be working with. So the potentiometer values, when they've been scaled, if you get values 6 through 10, you're going to be lighting up lights 4 through 0. 5 is going to light up no lights. And then if you get values 4 through 0, you're going to light up lights 5 through 9. So that's the scaling challenge that you've got. So we're going to go through the range of 0 through pixels num of lights plus 1. So that's going to give us, remember, we would normally go up to the range going up to but not reaching this value, but we do want to make sure that we reach the number 10 in here. So that's why we add 1 to this, because the number of lights are 10. If we put an 11 in here, we go from 0 to 10. Now, if our dial value is greater than 5, then what that means is that we're on the red side. So what we're going to do is we're going to check to see, do we need to light a particular pixel up in red? So we're going to see if I is less than or equal to the dial value that we dialed in. Again, we're going through all of our lights, and if it is, then that means we turn the light on. Otherwise, we turn the light off. And you can see by this calculation here, so if I is equal to the number of lights, then we're going to light up light 0, and as I gets progressively smaller, we're going to light up light 1, 2, 3, 4, And if we take a look over at our diagram, we see if we got 10, we're going to light up 0 through 1, 2, 3, 4 as our number gets smaller. What we have down here is what we do if we have the green lights, and we're going to check as we go through those numbers 0 through 10. If the number that we're going through is less than 5, that means we're lighting up the green side or the right side. And if the value that we're looking at is less than the dial value, we want to turn that off. Otherwise, we want to turn it on. And notice that these are in two different directions. That's to account for the fact that if we take a look, we're moving our red pixels from 6 through 10, but if we go in this direction, we're moving from 4 through 0. If we take a look at the green value, we have pixels num of lights -1 minus I, and that's because if you dial 0 through 4, we want to make sure that we go 9 through 5. So we're moving in an opposite direction. So again, the numeric value calibration is a little bit tricky here, but this is the code which will enable you to do that. So hopefully you got this. I know that this was a trickier one. It was more challenging. It was the last one, so it didn't take up a lot of your time. And if you struggled with this, well, now you've got your answer, so make sure you try that out.